Okay, guys, since our test is tomorrow, I wanted to go over the solutions of this so that you could check them and then you could see me during homeroom tomorrow or before school if you have questions. So the first one is the types of numbers. So remember that every number that we've dealt with so far is a real number and that it breaks off like this, like real, and then it goes either rational or irrational. And then from there, it can be an integer or whole number or natural number, in that order even. And remember that integers, whole numbers, and natural numbers are not fractions. They're not decimals. Okay, so just kind of looking at these five, like a regular number that you're used to is going to be all five of these. Square root of 12 is a number that doesn't work out nicely. It doesn't have a pattern in its decimal and it doesn't ever stop. And so that is just going to be real and irrational. -4 is going to go all the way to integers, but whole numbers don't include negatives, and so that's why it's going to stop right there. And the last one, a fraction is going to be only real and rational. Real and rational. Okay? So you got to know those words, so please look them over. The other ones here is I just want to go through solving these for you. So hopefully that we can figure them out. I don't know. My computer keeps going black. That's never a good thing, right? So the first thing I'm going to do here is I'm going to distribute, and I'm going to get 3b plus 6. And then I'm going to subtract 3b over here and add 5 over here. So I'm going to get 3b equals 11. I'm going to divide by 3. And I'm going to leave my answer as 11/3 or 3 2/3. But 11/3 is a simplified answer. Fractions. Again, more than one way to do this. To me, the easiest way is if you see an equation that has fractions in it to multiply by the common denominator. So between 3, 4, and 6, that common denominator would be 12. So I'm going to multiply everything by 12 here. And 12 divided by 6 is 2. So that becomes 2x. 12 divided by 3 is 4. And 4 divides into 12 3 times. So over here, that equals 9. So I'm not getting a common denominator. I'm multiplying to cancel out the fraction. And look at this problem now. It just becomes 6x equals 9. So when I divide by 6, I'm still going to keep it as a fraction. But if I can reduce my fraction, 9 and 6 are both divisible by 3. So that's going to become 3 over 2 or 1.5 if you prefer. Okay? Equations, they have one answer. Now, the next ones are absolute value. And so the big thing on the test is I just want to know, do you know how to set up these problems and solve them? So absolute value, remember there's two options. One option is that you just make sure the absolute value is by itself, and then you set it up and solve it. The other one is you get the absolute value by itself, and then you make the other side negative. So this becomes negative 2b plus 9. You have to change both of them, and then I'm going to solve that. So here I'm going to subtract b, and I'm going to add 9 over, and I get that b equals 14. And I'm going to check that that works when I plug it in. 14 plus 5 is 19. 2 times 14 is 28. Minus 9 is 19. And so that is an answer. And then over here, I'm going to add 2b this time to keep it positive. And I'm going to subtract 5 at the same time. So I'm going to get 3b equals 4. Divide by 3. And again, I'm going to keep it as a fraction, as 4/3. Oh, I guess I should check this. Does 4/3 work when I plug it in? Maybe I'm just going to use my calculator on this one. So on this side, if I do 4/3 plus 5, I get 6 1/3. And then over here, I'm going to do 2 times 4/3 minus 9. I'm going to get negative 6 1/3. Those do not equal each other. So please mark that out and say it doesn't work or say it's extraneous. Okay? This one, maybe you notice right away that there's a problem. Can this absolute value by itself ever equal a negative number? No, absolute value is always positive. So if you recognize that, that's no solution right away. And you can say that. If you don't recognize it and you set this up and you solve it, your answers are not going to work, okay? So I'm not going to promise that these are going to be pretty answers, because you're going to get 3x equals negative 17. You're going to get x equals negative 17 over 3. And so when you plug that back in here, you're going to get negative 17 plus 7, which is negative 10. But the absolute value of negative 10 does not equal negative 10. And so your answers don't work, okay? So I'm not going to do the second one, but it's not going to work either, all right? No solution. We also solved inequalities. We solved regular inequalities. We solved compound inequalities, and we solved absolute value inequalities. When you're solving an inequality, you have to use set or interval notation, and you have to graph it on a number line. So please pay attention to that as you're doing these problems on your test tomorrow, okay? So inequality, I'm just going to solve it just like an equation, except for I have to, if I need to divide by a negative. Sorry, my computer just went black again. I don't think it shows up on your screen, but I can't see anything. So I'm going to distribute that 2, and then I'm just going to get stuff together. So again, up to you how you do this. I like to keep my x over here, so I'm going to subtract the 2x over and subtract the 4 this way. If you do it the other way, you're going to just have to move your number at the end, so it's all going to work out the same. Negative 9x is greater than or equal to 2. Notice I've given you a lot of problems that have fraction answers, because fractions are okay answers. I'm going to flip my sign around though, because I divided by a negative, and I'm going to get negative 2/9. Don't give me a decimal. It's repeating, okay? So you can either write it in set notation or interval notation, where you say negative infinity to negative 2/9. Because it's included, I'm going to do the bracket. You're also going to make a number line here. I'm just going to say negative 2/9. It is included, and I want to shade left. Okay? This one, this is an and inequality, which means I can solve it all at once, right? It's what's happening where they overlap. So to solve this, I want to get x by itself. So I'm going to subtract 3 from all the sides and get negative 8 is less than 4x, which is less than 16. The goal is to get the letter by itself in the middle. So now I'm going to divide by 4, and I'm going to get negative 2 is less than x, which is less than 4. In set notation, it's going to look like this. In interval notation, it's just going to look like from 2 to 4, neither endpoint is included, so it's just going to look like this. And if I graph this, everything less than 4 and greater than 2 at the same time is going to be what's in the middle there. If it's an or inequality, it's 2 separate equations, okay? Number 11 and 12, absolute value, inequalities or equations. Step 1, get it by itself first. So the first thing I'm going to do here is I'm going to subtract 2, and I'm going to get the absolute value of A is greater than negative 17. Remember, less than means and, greater than means or. So this is an or statement, okay? So this is really important as we go to solve this, okay? If I set this up, the first one, I leave it alone, and I get x is greater than negative 17. Or I leave the absolute value alone, I flip my sign, and I change that to a positive 17. So this is where and or it matters what you get. This is a special case. I want everything greater than negative 17. So starting at negative 17 and going greater than that. Or starting at 17 and going less than that. If this were an and statement, the answer would only be where they overlap. But because it's an or statement, it means this or that, which means everything is shaded in on my number line. So the answer to this is actually all real numbers. And so the interval way of writing that is to say negative infinity to infinity. In set notation, it's kind of fancy, okay? Set notation, we say where x is a real number. And the fancy way of doing that is this little e and this fancy r. I think you should go with interval notation. Special cases happen when you see something like this, okay? Doesn't happen often, but or can have an answer of all real numbers. Let's do number 12. It's more regular, I think. Also, just real quick, think about this statement. If the absolute value is greater than negative 17, doesn't it make sense that every number you plug in will work there? Because every number's absolute value is bigger than negative 17. That's another way that you can figure that out. Okay, this one. Step 1, get the absolute value by itself. So to get rid of this 1/3, you could divide by 1/3, but much easier would be to multiply by 3, right? Multiply by 3 is going to cancel that out. So whenever you see fractions, think about multiplying by the denominator. And then I'm going to have 8q plus 5 is greater than or equal to 21. Less than and greater than or. So this is also an or statement. And I'm going to do 8q plus 5 is greater than 21. Or 8q plus 5, flip my sign, so it's going to be less than or equal to negative 21. And now I'm just going to solve both problems, okay? So I'm going to subtract 5, and I'm going to get 8q is greater than or equal to 16. Divide by 8, and I get q is greater than or equal to 2. Or over here, if I subtract 5, I get 8q is less than or equal to negative 26. And I'm going to divide by 8. And I'm going to get q is less than or equal to negative. Both of those are divisible by 2. So I'm going to do negative 13 over 4. In set notation, it would look like this. Trying to move this out of the way a little bit. If I'm going to graph that, I'm going to have 2, and I'm going to have negative 13 over 4, both included, but now this one does work out. Everything greater than 2 or everything less than this. So this is a normal or statement that you're used to seeing where they go in opposite directions. In interval notation, that would be negative infinity to negative 13 fourths included and 2 included to infinity. Okay? The last thing that you're going to have on your test is a story problem. And so I gave this one, I don't know if I like this one, but it's here. But you're going to have a story problem. You're going to have to write an inequality, write an equation or inequality, define your variable, and solve it. So it says Miss Hawkins is taking her science class on a field trip to a museum. She has $572 to spend on the trip. There are 52 students that will go to the museum. The museum charges $5 per student, and Miss Hawkins gets in for free. If the students will have slices of pizza for lunch that cost $2 each, write an inequality and solve it to see how many slices each student can have. Okay, this one, there's a lot of information here, right? And so it's kind of up to you on how you put it here. But to me, the total amount she has to spend is the 572. So that's kind of what I think about on one side, but you could totally do it another way. So she has 52 students times $5 each to get in, right? So like think about what we're going to spend. So this is like what we're going to spend on this side has to be less than or equal to how much money she has, right? Total amount. So she's going to spend $52 times $5, 52 students times $5 a piece. She doesn't have to pay anything. And then they're going to spend $2 on each slice of pizza. And we want to find how many slices we can have. So I'm going to use P. So over here, I'm going to say P equals number of pizza slices. And we have to go less than or equal to 572. Maybe you go ahead and subtract the 52 times 5 from the 572, and that's okay because we're going to end up at the same spot. We don't have to have exactly the same thing. That's $260 to get in. So I'm going to go ahead and subtract that over. So I'm going to get 572 minus 260 is 312. And then I'm going to divide by $2. Oh, I've messed something up, haven't I? Because what happens when I divide by 2? I get 156 pizza slices. That doesn't make sense. There's 52 students, right? So I need a 52 in there too. I need to divide that by 52. So where would I put that 52 to make my, because I can get the answer, but my equation doesn't make sense right now. Because see, look, I get the pizza slices are less than or equal to 156. But that's how many total pizza slices she can buy. So then we're going to divide that by 52. So I think I need to say, I'm going to go back to my equation. I think I want to change it to like $2 a piece times 52 students. Would that fix my problem? Because now I'd still have a 52 over here, and I'd still have a 52 to divide by. So I could take 156 divided by 52 and get 3 slices a piece. So 3 slices a piece. Now this doesn't account for Miss Hawkins having anything, but it doesn't say whether or not she's eating pizza. I'm assuming that hers is separate. But do you see how I took my answer and it didn't make sense? There's no way they could have 156 slices a piece. So I had to go back and adjust my equation. And that's what I want you to do when you see a story problem. See if your answer makes sense in the problem. So please see me if you have questions about this. You can see me before school. You can see me in homeroom tomorrow. In class, we will pretty much get started on our test pretty quickly. So if you have more than just like a simple question, please see me before class starts tomorrow for your test.